Welcome to this first video on limits, of which you're going to discuss the formal definition of limit and just to understand what this concept of limit is. Now, to do that in the most simple way, I want us to consider the function y is equal to x squared. So let's consider this particular equation, of which we know, of course, this equation of a parabola. That should be a parabola. So suppose you're supposed to plot this in a graph that we have just drawn here. So we can have different values of x and their corresponding values of y using the equation here. So you can begin from -2, then -1. You can go to 0, 1, 2, even 3 as you go downwards. So let's check the values of the corresponding values of y for this particular function. So if x is -2, if you place -2 here and -2 squared will give us +4, because -2 times -2 is +4. The -1, if you take it and place it here, -1, again if you square that, you are supposed to get +1. Then 0 squared will be 0. 1 squared, just substituting the value of 1 there, will give us that y is supposed to be 1. Then for 2 also we'll get 4 and 9 and vice versa as we go. So you can decide and plot this in this graph. For example, for -2 here, x value, we have 4. You can put a small plotting there. Then for -1 we have 1. For 0 we have 0, 1, 1, and then 2, 4. As you go, if you add 3, we'll have to add 9 there. So you can draw this graph, we can plot this curve, a nice smooth curve, just a sketch there, and then have it as y is equal to x squared. Now that is what we have. So what I want us to check, I want us to analyze the values of y for their corresponding values of x. For example, if x, this is x axis, remember this is y. So if x is 1, then the corresponding value of y is 1. You can read from the graph. If you are to have maybe 1.5 somewhere here, you'll get a corresponding value of maybe maybe 2.25. If you add 2, you have 4. If you add 2.5, you'll have 6.25 up there, then 3, 9, like that. So what I want you to notice is that if you pick a particular value, let's say 2, the value of y, corresponding value of y is 4. Now, if you start approaching these 2 from any of the sides, let's say that you are moving from these 3, you are approaching here from 3 of 2.9, 2.8, 2.5. As you approach 2, you will be finally, as you approach 2, the value of y must also be approaching 4. You can try that with the 2.8, 2.7, 2.5, 2.2, 2.1 until you have 2, that all those values will be approaching 4. Similarly, if you approach this value from this left hand side, that is from 1 approaching 2. So as the x value is approaching 2, the value of y is approaching 4. Now this value 4, which is being approached, which the value of y is what we are calling the limit. So before that, we can just put this down, that as values of x approaches, or we sometimes use the word tends, approaches 2, then the values on the y-axis, approaches 4. Now notice that is happening from both sides. So therefore we simply say that 4 is the limit of the function, as x approaches 2, or as x tends to 2. So any of the formal definition that you'll want to give. So when talk of the idea of limit, it's just about substituting the value of x in the function, whatever you can even get as you use it in that particular curve. For example, consider this example. If given to find maybe the limit, example, you are told to find the limit of x squared as x approaches, let's say 3, then how do we write that? We write it by saying that the limit of x squared, then we normally say down here x approaching, so that's the symbol for approaching 3, and this will be equal to, you just substitute the value of x inside here. So this is the same as 3, then you square that, and this will give us 9, just like that. So we say that the limit of x squared as x approaches 3 is given as 9. Or sometimes we write in short as limit, just lim, of x as x tends to 3 of this x squared will be given by 9. So if you are asked to find the limit, then it's just about substituting, of course. And so the idea of limit is nothing so much difficult as such. So we normally use we can use the letter or symbol, just L, to represent the limit. So we will say that the limit, so in general, we can say that the limit of a given function, let's say that function f of x. So this is a function of x, like y is equal to 2x. So y is a function of x. It depends on x. As x approaches a certain value, let's say a is supposed to be equal to L, and this is what forms the formal definition of a limit. So notice that this symbol simply means tends to or approaches, and you have seen it in the graph. This L is the value of the limit. In fact, this one, if you from the graph, just the value of y, and then the f of x is the given function. A are just values in x-axis, then L will be all the values in the y-axis. F of x is our function. So maybe the last one, if told to find the limit of this function 2 minus 3x squared plus x squared as x tends to 0, then this one you will get, you just need to substitute in the values. So this will be 2 minus 3 times 0 squared, just 0, plus 0. So all this will give us 2, and that is the limit. So when told to find the limit, then it's just about substituting, and you have seen there just the idea of some value of some values in the y-axis of which we get for their corresponding x values. Okay, so that's all for this video. So in the next video, we shall look at some of the properties of limits. Then from there, we can now start to evaluate different types of limits based on some conditions and rules which are given. Thank you.